Elasticsearch doesn't search raw text, it fragments it. The analyzer pipeline is the factory that decides how a sentence gets chopped into searchable pieces, and the tokenizer you choose changes everything. Every analyzer is a three-stage conveyor belt. Character filters clean the raw input, stripping HTML or substituting characters. The tokenizer slices the clean text into tokens. Token filters then refine each token through lowercasing, stop word removal, and stemming. An analyzer is a reusable bundle of these three components, applied at both index time and search time. The same analyzer on both sides is what makes matching actually work. The standard analyzer is Elasticsearch's default. Its standard tokenizer splits text on Unicode word boundaries, which means punctuation like hyphens, dots, and slashes all act as separators. Run Power User 2024 through the standard tokenizer and you get 3 tokens: Power, User, and 2024. The hyphen acts as a breakpoint, severing the compound term into pieces. The Whitespace tokenizer takes the opposite approach. It splits strictly on whitespace characters, spaces, tabs, new lines, and ignores punctuation entirely. Feed the same Power User 2024 into the Whitespace tokenizer and you get just 2 tokens: Power User and 2024. The hyphen stays glued to the word because Whitespace doesn't care about punctuation. The side-by-side comparison reveals the real impact. Standard produces Power, User, and 2024. Whitespace produces Power User and 2024. Searching for Power User as an exact phrase matches the Whitespace tokens, but fails against standard analyzed text, unless the query itself gets analyzed the same way. At the opposite extreme sits the keyword tokenizer. It emits the entire input as a single, untouched token. Perfect for exact match fields like product IDs, tags, and zip codes where fragmentation would break the match. The tokenizer you pick controls how text gets fragmented, and that directly drives the recall versus precision trade-off in your search results. Choose wrong, and your users either get noise or miss the hit that should have been obvious. Before running any analyze queries against Elasticsearch, we need to confirm the service is up and reachable on its default port. In this demo, we'll open a terminal, verify the cluster responds, and then compare how different analyzers tokenize the same piece of text. Let's begin with a clean screen. We start with the clear command, a simple habit before any diagnostic session. It wipes the visible buffer so that only our intentional commands and their output remain, making the session easier to read and to follow when reviewing logs later. Next, we hit Elasticsearch's root endpoint with curl, s localhost, 9200. The S flag silences curl's progress meter, so we see only the JSON response. A healthy cluster reply includes the cluster name, a randomly generated UUID, and a version object. Proof the node is alive and accepting HTTP. With the cluster confirmed live, we test the _analyze API using the standard analyzer. The standard tokenizer lowercase the input and splits on word boundaries, so a hyphenated token like Power User splits into 2 terms and the trailing digits form their own token. Now we rerun the same query, but switch to the Whitespace analyzer. This tokenizer splits strictly on Whitespace and preserves original casing. No lowercasing, no punctuation splitting. Notice the hyphen stays attached and Power User remains a single token. Finally, we test the keyword tokenizer, which emits the entire input as a single token regardless of spaces or punctuation. This is the right choice when you need exact match queries. For example, searching product codes, tags, or identifiers that must not be split. The progression is clear. Standard aggressively normalized our text, Whitespace preserved case but split on spaces, and keyword emitted the input verbatim. Choosing the right analyzer or tokenizer at index time is what determines how your search queries match documents later. Welcome to this hands-on demo. We'll explore how Elasticsearch's analyzers break text into tokens by querying the _analyze API directly from the terminal. By the end, you'll see exactly how the standard analyzer treats hyphens in compound words like Power User. We start with clear to give ourselves a fresh workspace. This is purely cosmetic, but keeps the demonstration focused on each command's output without clutter. Before analyzing any text, we confirm Elasticsearch is reachable with curl to localhost on port 9200. The cluster responds with its name, version, and a green cluster UUID, confirming the service is live. Now we test the standard analyzer on Power User 2024. We post to _analyze, specifying the analyzer and the text. Look at the tokens returned, Power, User, and 2024, 3 separate tokens, because the standard analyzer splits on the hyphen. For contrast, we swap the standard analyzer for the Whitespace analyzer. Notice the output now, just 2 tokens, Power User and 2024. The Whitespace analyzer only splits on spaces, so the hyphenated word stays intact as a single token. Finally, we test the keyword tokenizer, which emits the entire input as one token, no splitting at all. We give it just power user, and it returns the whole string unchanged, preserving the hyphen as part of the single token. In this demo, we will use Elasticsearch's _analyze API to compare how different analyzers tokenize the string, power user 2024. First, let's clear the terminal so we have a clean workspace. Before we test any analyzers, we verify that Elasticsearch is responding by hitting the root endpoint. The cluster info, version, and a yellow tagline confirm the server is up and ready. Now we run the standard analyzer against power user 2024. The standard analyzer breaks the string into 3 tokens: power, user, and 2024. Notice that it lowercased everything and split on the hyphen, treating the hyphen as a word boundary. Here is the key demonstration. We switch to the Whitespace analyzer on the exact same input. The output now shows only 2 tokens: power user and 2024. The hyphen is preserved as part of the token, and casing is kept intact. Whitespace only splits on actual spaces, nothing else. To make the contrast even sharper, we run the keyword tokenizer, which splits on nothing at all. The entire input power user comes back as one single token, exactly as written, with start and end offset covering all 10 characters. Elasticsearch offers several built-in tokenizers, each with a different philosophy for breaking text apart. At one extreme sits the keyword tokenizer. It never splits anything. The entire input string survives as a single token, exactly as you handed it in. We start by confirming Elasticsearch is running. A simple get to localhost on port 9200 returns the cluster name, version, and a tagline, proof that the service is alive and responding to HTTP. Now we send a short string, power user 2024, into the standard analyzer to establish a baseline. The standard tokenizer splits on word boundaries and lowercase everything, so we get 3 separate tokens. Switching to the Whitespace analyzer changes one thing. It splits only on whitespace, never on punctuation. The hyphen stays glued to power and user, but we still get 2 tokens because of the space between the words and the digits. Finally, the keyword tokenizer. We pass it a simple string and specify the keyword tokenizer directly. No analyzer pipeline, no lowercasing, no splitting. The response contains exactly 1 token, identical to the input, occupying the full offset range. This is what makes the keyword tokenizer ideal for IDs, product codes, tags, and email addresses. Anything where splitting would destroy meaning.